This is Christine Kirkpatrick from the FAIR Digital Objects Forum with a practical explanation of a FAIR digital object, or FDO. FDOs can include any digital content such as data, metadata, software, schemas, semantic assertions, and more. At the FDO level, we abstract away from the encoding, structure, and semantics applied to the content associated with the FDO. This leaves us with the data, a structured sequence of bits stored in some repository or exchange via some transmission lines. For simplicity, let's assume that there is a bit sequence as shown here in the diagram. Such a sequence of numbers is digital data stored somewhere, but we cannot call it information since we cannot interpret it. We would like to ask many questions about such a sequence of numbers, which would allow us to eventually make use of it. What is it? How is it created? Where is it stored? How persistent is it? Who is allowed to access it? How can we reuse it? How should we interpret it? Which operation can we process it with? To receive answers to these questions, we currently would have to access many different information sources, which include humans, such as data experts, data managers, institution managers, and system operators. This is because different types of metadata, such as the usual descriptive metadata, deep contextual and provenance metadata, metadata about rights and licenses, etc., are required. Currently, most metadata is still in the heads of a few experts or scattered in some files, spreadsheets, or similar. This is a slow, time-consuming, inconvenient, and often erroneous process, and it is not a process that can be applied by machines that are used increasingly in automatic workflows. Except for some advanced cases, we still handle data as if it is a few files and as if those wanting to reuse data will receive it in person. To be fit for the emerging data challenges, we need to associate all of the information needed to answer the above questions tightly with the data. We should be able to ask the bit sequence about its properties. This is exactly what is intended with digital objects. Virtually, we should organize all relevant information in such a way that the answers to the above questions can be found closely and persistently associated with the bit sequence. To accomplish this, we assign this bundle a global, unique, resolvable, and persistent identifier, or PID, which is augmented with references to all required informational entities for finding, accessing, interpreting, and reusing to make the data fair. A PID system is globally distributed, ultra-fast, and highly secure database which resolves a PID to a set of attribute value pairs. These attributes can include values characterizing the checksum, the type, and the version, but also include references to where to find the descriptive metadata, the rich contextual and provenance information, the rights record, and if needed, the blockchain, which includes transaction and contractual information. The persistency of the PID system is crucial. Achieving persistency is not a technical issue, but a social one. If the interested community is taking care of the persistency of the PID system, then the values associated with PIDs are also persistent. Trustworthy PID systems exist, which we can use for digital objects. We call this a digital object, which has a few excellent characteristics. Digital objects are identified by a PID, which is resolved by a PID record. Digital objects support abstraction. Digital objects support persistent binding. And digital objects support encapsulation. Many people throughout the world have implemented systems based on the digital objects concept, such as the cloud system builders and their object stores, the international publishing industry with digital object identifiers, or DOIs, the international film industry using universal media identifiers, or EIDRs, and many large scientific collaborations such as the International Climate Modeling Community. From the web community, the signposting approach has been suggested to implement the concept of digital objects. However, There is no interoperability between all of these approaches at the digital object level, and in general, the approaches are not yet machine actionable. For example, machine agents are not yet able to interpret all information they receive after resolving a PID. The work on fair digital objects began in 2019 with the intention to overcome the shortcomings of the digital object concept. The FDO Forum is the initiative that works on the FDO specifications, which include the following aspects: identifying different configuration types of FDOs, specifying PID profiles, specifying the set of mandatory kernel attributes, specifying a set of optional kernel attributes, specifying a data type registry, and making recommendations about aspects such as granularity, versioning, and mutability. All these specifications need to be made such that they cater to different implementations. The International FDO Forum began its work on these specifications in January of 2020 and will present a full FDO specification in October 2022. It has a signed collaboration agreement with the official German DIN standardization organization, with the intention that the full FDO specifications will be turned into an international ISO standard so that the interested community can rely on its stability. A variety of large collaborations and research domains are making use of the specifications already, which are converging to widely agreed upon working draft versions. More information is available on our website at fairdo.org.